Hello everyone, welcome to Digital Technique Laboratory. Today we will learn about combinational circuit. We have three main topics about combinational circuit. There are definition of combinational circuit, uses of combinational circuit, and then application of combinational circuit. The first one about definition of combinational circuit. Combinational circuit is a circuit that consists of logic gate circuit that the condition of the output only depends on the current input condition and doesn't depend on the previous output condition. Uses of combinational circuit. There are 6 uses of combinational circuit. The first one is encoder, the second one is decoder, the third one is multiplexer, and then demultiplexer, half and full adder, and then half and full subtractor. Okay, let's start from encoder. Encoder is a combinational circuit is used to change information into certain code. For example, binary encoder, it changes one active input into a unique output combination for each input. The characteristic of encoder, there are more input than the output. Okay, the second one is decoder. Decoder is a combinational circuit that is used to decode the information or data that has been coded. One of the examples of decoder is the binary decoder. The characteristic of decoder, there are more output than the input. Okay, the next one is multiplexer. Multiplexer is a combinational circuit that is used to select one of two power of n bit input signal, which then be passed to one output path. So there is one output from one of these inputs. Okay. The next one is the multiplexer. The multiplexer is a logic circuit that receives one input data and distributes that input to several available outputs. So there is one input and there are two conditions S1 and S0, and then there are 4 outputs. This is an example of 1 to 4 the multiplexer. And then we have half adder. Half adder is a secret to sum up two variables which is of it is 1 bit wide and produce one variable which is 2 bits wide. So like the example, there are A and B for input and then carry and sum for output. A and B. So we add these two input, so the output become the value of the sum of input. For example, A plus B, 0 plus 0 equal 0. And then the carry still 0. And then 0 plus 1 equal, the sum is 1. And then the carry is still 0. And then 1 plus 0 equal 1. And then the carry is still 0. And then A and B, 1 plus 1 equals 0. Because this is a binary operation, so there are not 2, 3, 4 or more number. So there are only 1 and 0 number. And then the carry's value become 1. And then the full adder. The difference between full adder and half adder, there is a carry in for the sum. And then the next one is half subtractor and full subtractor. Half subtractor is a circuit to subtract two 1-bit wide variables and produce a 2-bit wide variable. Like example, we have two input, there are A and B, then two output, B out and D. So A subtracted by B, 0 subtracted by 0 equals 0. And then B out's value is still 0. And then 0 subtracted by 1 equal 1. And then B out's value become 1. And then the last one is for subtractor. For subtractor is a secret to subtract three 1-bit wide variables and produce a 2-bit wide variables. The difference between for subtractor and half subtractor is for subtractor has bin for the subtraction. Okay, there are example problems. You can read it by yourself to improve your knowledge about combinational circuit. Application of combinational circuit. Combinational circuit is applied for several needs for manufacture electrical. The example is the multiplexer is widely used in telecommunication devices, and then application of decoder in 7 segments. Okay, thank you everyone. See you next time.